So back to agents. 2025 is the year of AI agents. You are going to hear about them a lot, and a lot of people, including me a few weeks ago, didn't really know what an agent was. This is a Reddit post. If anybody is a customer of Salesforce, Salesforce are doubling down on agents. They started this Agent Force thing, which is essentially a no-code or a low-code agent builder. Salesforce are massively pivoting into this. A lot of other companies will be doing this as well. You are going to hear a lot about AI agents. So what are they? Well, I'm going to show you what an AI agent really is, first principles thinking, intrinsically, what an AI agent is, how it's not a massively new concept, and how you can build one yourself. So an AI agent is an autonomous system that perceives its environment, makes decisions, and it takes actions to achieve specific objectives. So unlike just a normal ChatGPT chat, the idea of an agent is that you give it a goal or you give it an objective, and it uses traditional machine learning techniques and LLMs and other types of process automation to work out how it can achieve that objective, and then it sets about with automated tasks to get there in the end. So there's just a couple of screenshots I put here on the bottom of a couple of AI agents that are sort of around. GPT Research is really cool. That's an open source project that you can download that uses a bunch of different models of Hugging Face, and you give it a topic you want it to research. So you could say, go and research the city of Sheffield, and it will work out a research plan for that. It would call LLMs, it would scrape the internet, and it would generate you a research report. So it's a really autonomous, goal-driven agent that's really cool that you can play around with today. OpenAI are working on an agent that's going to be called Operator. You're going to hear all about that soon because it's OpenAI, so of course you're going to hear all about it. And Devin. Has anybody heard of Devin? Hands up if you've ever heard of Devin. Right. So Devin is apparently an AI software engineer. So the goal that you give Devin is fix a bug in my code or implement a new feature. Now, Devin's rubbish. Honestly, I've been managing software engineers for like almost 10 years. I would put this thing on a pip before it could even say the word pip. However, it is a sign of things to come. It's always worth remembering with things like Devin that this is the worst it's ever going to be. So in a few years' time, this idea of, AI software engineers are rubbish, that will start to fade, and they might actually be coming for your job if you're a software engineer. It's just something to think about. So AI agents are happening. But what really is an AI agent? Well, I've come up with a definition of an AI agent I think makes it really simple to explain, right? An AI agent is the intersection between process automation and large language models. And then a bunch of other stuff on the top, but none of this is particularly new. This is all just stuff that happens when you intersect large language models with process automation. And I put LLMs specifically. Obviously, there's other types of foundation model. There's things like diffusion models for images, but large language models in particular, because if you can represent some kind of process as text, it doesn't have to be English text, it can be JSON, then you can send it off to a large language model, and suddenly an LLM can control your process. And that's what I'm going to show you today. So what actually is a process? What's process automation? Process automation is this kind of stuff. There's a tool called Make. It's event-driven logic. The events happen somewhere in a system, and it will go through some kind of automated process, and it will produce an effect. So here we've got a Notion items created, and it creates a Google Calendar event. Here's another screenshot from Zapier. The process here is a lead is generated in a platform. It goes on to send an email. AWS Lambda step functions. This is another example of a really visual process automation tool that I really like. I've done a lot of talks on AWS Lambda step functions before because they provide this kind of UI like Zapier and Make have, but they also, you can define all this in code and it's calling Lambda functions. It's very technical. AWS Lambda step functions blurs that line between a kind of clicky UI where you can build a process and actual software engineering where you're writing code to do these kinds of things. So this is a really cool tool, but process automation is the bread and butter of computing, and it doesn't always have fancy UIs like this, right? Process automation is often just if statements or complicated versions of if statements. Process automation existed on the Apollo moon lander. It exists in pretty much every factory all the way around the world. Every time you buy something on Amazon, you're kicking off some kind of automated process with the goal of making you spend more money on Amazon. So process automation is not a new thing. It's just a new thing when you start to combine it with LLMs. Second, what else? Yeah, here's another example, right? So everything I've said about process automation, imagine a ticketing support system, right? Zendesk is used for customer support tickets, right? And I don't know if you can read this on the screen, but Zendesk has a feature where you can set up automations, just like we've been looking at, right? So you can say here, if a ticket has been open or in a solved state for more than 96 hours, then set it to closed. Now, I want you to think about this image. I want you to think about what this kind of UI, because UI exists like this in pretty much every single application that you've ever used. But what is it really doing? You're basically creating a process that can be represented as a piece of text, and then you're running that process on the back end. And essentially, that's it. Companies have used traditional machine learning techniques to make the running of a process or falling through a tree or following these rules much, much smarter than just a bunch of if statements. There are companies that have used machine learning to run through lots of paths in a decision tree and pick which one was best. Think about like a chess algorithm or chess computer. It runs through lots of paths in a process and it works out which is the best final move. So they can be quite complicated. They're not always basic if statements. But they're not revolutionary. They're not revolutionary in that they're suddenly going to change the world and give us AI agents. This isn't an AI agent, but I want you to have a think about what you could actually do to turn this into an AI agent. Which brings us on to the other half of our Venn diagram, which is large language models. Now, I'm not going to sit here and explain exactly what a large language model is. There's a sort of rough architectural diagram here. But a basic definition of a large language model is it's a pre-trained model that can predict the output for a piece of text, and I put that in brackets because they are multimodal, but let's go with text, from some input text. And that word predict is very important because unlike the majority of processes that have been automated with code are usually deterministic. There's usually one path through that tree. Large language models work much more like a weather predicting app, right? So if you go on BBC Weather and you ask it whether it's going to rain tomorrow, it will not tell you, yes, it's going to rain tomorrow, or no, it's not. It will say, there's an 86% chance of it raining tomorrow. And that's because weather prediction apps use probabilistic, non-deterministic ways to predict the weather, which is exactly what LLMs do. Which means if you give an LLM a prompt, such as tell me a joke, it will give you what it thinks is probably the kind of response that you wanted from that prompt. And that word probably is important because if you all go on your ChatGPT apps and ask it to tell you a joke, it won't give you all the same joke. It's not that deterministic. So it just sees that. It doesn't actually have a sense of humor. It doesn't understand what a joke is. It just thinks this is the kind of response that I want to generate when somebody gives me this input. And sometimes it gets it wrong. This is actually a fake example, but there have been a lot of examples of ChatGPT taking like a maths problem, and just because the output there looks like it could be the response to that input, it says, yeah, I'm about 80% sure that's right, then it sends it out. It's non-deterministic. However, despite being non-deterministic, they're still incredibly useful tools. There's a couple of other features about large language models before I move on, right? The first thing to know about large language models is that they're stateless. So everything on the right-hand side here doesn't maintain state. Every time you call ChatGPT, you're sending the entire conversation history off to ChatGPT. Also, they're pre-trained. I started this sentence with the word pre-trained, right? Which means that the knowledge limit to ChatGPT is defined on a certain date. So GPT-4, the cutoff for that was December 2023, which means if a new word has entered the English language since December 2023, GPT-4 won't know about it. And the way I like to think of that is my granddad was a physics teacher. My granddad retired in the 2000s. He did his degree in the 1950s. In the 2000s, he was teaching things to secondary school children that had not been invented in the 1950s. The world changed. And the only reason he was able to do that was because he was continually updating his knowledge of the world. LLMs don't do that. LLMs are pre-trained at one point in time. And sure, OpenAI might produce new versions of LLMs, they've got more up-to-date data in them, and they'll modify them, but they're new LLMs, basically. OpenAI's got loads of different ones that it's trained at different points in time. An individual LLM doesn't generally learn anything new. So the only way you can make it do new things is if you add that functionality in afterwards. I think that's it for things. Okay, so I want you to think about what we could do if we introduce an LLM into this Zendesk ticketing system. Well, the first thing that the LLM could do is it could probably replace this UI entirely. Because if you think about what a UI like this is actually doing, right? This is just a way for you to create some kind of configuration object. So all of those boxes and all those inputs and stuff like that, usually just resolve to a piece of JSON. It's nearly always JSON. That JSON gets sent off to your backend, it gets stored in the database, and when this rule is ready to run, it will load this piece of JSON from the database, and it will follow the instructions inside the JSON. Your process that runs this automated workflow doesn't care about the drop-down boxes, it doesn't care about the font size or any of that sort of stuff, it just cares about this piece of JSON. So, What if you could have an LLM produce that piece of JSON just from a prompt? The same piece of JSON, then it will work in exactly the same way. And that's actually very easy to do. You just need to give it a schema. So this on the left-hand side is, you probably can't read it from here, but essentially, if you've ever done like JSON schemas, this is another piece of JSON that describes the fields and the structure of the piece of JSON on the right, and it describes it using English language. So I'll read this to you. The top field here says that there's a property called rule ID, and it is a unique identifier for the rule. This should be short, descriptive, blah, blah, blah. So every field in this piece of JSON is described on that one on the left. So if you can take that piece of JSON on the left, which is text, and pair it with a piece of user, like a prompt, which is also text, you can send that off to any LLM and get it to generate this JSON on the right-hand side. And you can do this just in the ChatGPT UI. So if I just paste into the ChatGPT UI, here is a JSON schema for an automation rule. Using this schema, create a JSON object for that rule according to this user prompt. And then whatever the user wants to say, how they describe their rule, paste it in there. And this is just using the standard ChatGPT UI, remember, and it will do it for you. It will say, here is a JSON that matches that schema, save that piece of JSON to the database, and then you can run your rule on it, and suddenly you've replaced your entire user interface with a prompt. Now, I know what you're thinking. I don't want a prompt. I like to be able to fiddle with buttons. But there are a huge number of advantages if you can change your entire system to accept prompts instead of massive forms and things. One of those advantages is when you come to integrate it into a wider system. And this is really getting into the crux of why we're going to have AI agents soon. Because if you can resolve your entire JSON API into a text prompt, then suddenly it can interface with pretty much anything else that also uses text, including humans. So you could have it email somebody and then read the response to that email. You could have it post some text into Slack and then read the response to that text in Slack. Suddenly your JSON API goes from just being a really rigid user interface inside Zendesk or whatever, into being something that can communicate just like people do. So even though prompt-based UIs might not seem like this absolutely groundbreaking moment, they really are, because they allow your backend to communicate the way that a person would communicate, and they allow your backend system to interact with the world just like a person would, which means an AI agent built on top of this can interact with the world just like a person can. So think about, oh yeah, that's it. It doesn't stop there, right? So this is our user interface that we're going to replace with a prompt. But think, now we've got the capability to use language models with this JSON schema. Think about what else we can do on top of this. This is a very rigid, structured automation rule. This automation rule says that when the ticket has been set to solved for 96 hours, we're going to close it. Well, now we've got the ability to use LLMs. What if our system sent an email out to the user and just said, here's a summary of your ticket, here's all the activity, are you happy for us to close it now? And then the user will write an email back, again, using your text-based interface, and the user might say, yeah, that's great, please close it. And so then you can kick off the next part of your workflow. So you can make this so much smarter if you give an LLM the capability to actually talk to the user in natural language. And you're incorporating that LLM into your automated process. You could do other stuff as well. I mentioned before, one of the features of AI agents is that they can learn and they can improve themselves. Well, let's say at the end of every customer support ticket, you ask an LLM to summarize your support ticket and send it out to the user and say, how happy are you with the resolution of this support ticket? And they say 1 to 5, Likert scale, and really happy with it. You can take that summary, create an embedding for it, put it in a vector database, take the piece of feedback from the user, pair that with it, and over time, your system can build up a pattern of which customer support tickets are given a satisfactory score and which ones are given an unsatisfactory score. And then you can write some automated code that will go through that and maybe even change this process for the ones that are unsatisfactory. So you can have a completely autonomous system, which is essentially an AI agent, completely autonomous system that gathers feedback from customers, pairs that feedback to successful closed support tickets, and adapts your workflow as it is. So when all these things come together is really when these start to become AI agents. This is the architecture of an AI agent. And basically, what you can see is it's a normal backend architecture of any kind of process automation with a large language model on the sidebar. You usually have an orchestrator. So there's usually a piece of code that runs. And this is, again, the same with most automated processes. There's usually some kind of thread that's running and it's checking. And it's using the LLM as a tool to decipher inputs from your user and working on schedule and stuff like that. Context management is here because LLMs are stateless, so you need part of your system that can store that whole context and send it off each time. But none of this is particularly groundbreaking. What's groundbreaking is the incorporation of a large language model into this wider automated process. So I've got a very quick demo in that case to show you. The demo I've got for you is the absolute classic case of an AI agent, a customer support agent. Has anybody used a chatbot on a website for customer support? What was your experience with it? Generally, yeah, generally thumbs down. The reason people don't like chatbots is because they don't actually help you. They can't actually do anything. They just say to you, oh, sorry about that, you need to contact customer support, right? Chatbots are about to get a whole load smarter because of what we've just talked about with incorporating LLMs into them and being agents. So the demo I've got for you, I can't play this part at the moment, 1 second. The demo I've got for you, I've pre-recorded because naively, I thought pre-recording a demo would be less chaotic than trying to do it live. And then I got scuppered by Wi-Fi. Right. Cheers, play. There we go. We're cooking with gas, right. Okay, this is a quick 5-minute demo to show you how to build an AI agent. Take this away, go and build one yourself. Come to the AI hackathon and build one of these. The demo I've got for you uses the OpenAI Playground. Now, for those of you that have used OpenAI before, you'll know that there's 2 ways to interact with OpenAI. You can either go to chatgpt.com and you can talk to it like a chatbot, or you can use the API. And the API gives you all the functionality that you're going to need if you actually want to build a system for it. OpenAI's Playground, which is platform.openai.com, is essentially a UI around their API. So the Playground has got a bunch of features on the right-hand side here that are essentially changing API parameters. So you can go through and you can select a model, you can go down, you can change temperatures, max tokens, all that sort of stuff. What you're doing here is you're controlling the API call that is made to OpenAI. They also give you this code button at the top here. So at any point, you can see the code that you would use to call the OpenAI with all of these parameters and all of these settings. And the way it works is you have a system message, which is sent with every message chain, and then you have some user messages, which come from your interface. So if you imagine a customer support bot, the user might come along and say hello, and the LLM generates a response to that, which just says, how can I assist you today? So we haven't done any agent stuff yet. We're literally just using the LLM as a kind of chatbot, basically, right? And one of the problems with using it as a chatbot, I'll just pause that for a second, is that they tend to hallucinate. So if you can read what it says on here, the user said hello, the assistant has said, how are you today, or how can I assist you? The user has said, change the delivery address of my order, and the chatbot has said, sure, I can help you with that. I need some details. Give me your name and address. This is going to end badly. So the user's going to come along and they're going to say, my order number is this, and my address is 1 Sheffield City Centre, S11DJ. That's actually the postcode of Gatecrasher. Did you know that? S11DJ, postcode of Gatecrasher. Anyway, and then the assistant says, I need to go back a little bit because I talked over it. The assistant says, thank you for the information. However, I'm unable to make changes directly to your order. I recommend that you contact customer service. This is why people hate customer support chatbots, because they can't actually do anything. And they've led you on. They've hallucinated and made them think that they could actually go and change your order. So what we need to do is we need to give it the capability to update your order. And that's possible. It's possible with the help of a feature of OpenAI's API called function calling. Oh, there we go. So function calling is this idea that you can create a function. It's because I'm near that, isn't it? The idea that you can create a function that the LLM can call when it wants to. Now, there's an important caveat here. If anybody's used function calling or heard of function calling before, what I said before about LLMs being stateless and pre-trained always holds true. So when you use function calling on an LLM, it's not actually calling any functions. OpenAI isn't going to go off and get the stock price for this function. What you're doing is you're saying to an LLM, if at any point during the conversation you need to call some kind of functionality, this is a function that I've got that you can call on my end. So I'm just going to use their little chat fonts to create a function here. So we can create a change delivery address function, which will go off and kick off a workflow. And what we're doing is we're telling the LLM that that function exists. So here we go. We've created a function called change delivery address. and there's a description for that function, which is very important because the LLM needs to read all of this and understand what this JSON means. And you can see that it creates a function with some properties for street name and city and postcode and stuff like that. So now what we can do is we can make calls to the LLM, but with every call, it knows that it has the capability to call a function. So now, if I come in and say, change the delivery address of my order, the assistant will still come back and it will still say, what's your address? But this time, if I type in my order number and my address, 1 Sheffield City Centre, Sheffield S11DJ, look what the LLM is going to do now. Instead of saying, oh, you need to contact customer support, it's going to give you this. This is a special kind of response that you get back from the API, and it's called a function or tool call response. What the LLM is saying is that I can't respond to the user right now. I actually need to do something in your platform. So what it's saying is I want to call a function that you've given me called change delivery address with these parameters. So you can return to the LLM, success true, and it will then respond to the customer saying, thank you, your delivery address has been changed. So just by adding that one function call in there, we've given the LLM the ability to essentially do stuff for us, to take action, which is what AI agents are all about taking action from user requests. And you can see here, if you want to read all this JSON, it's quite interesting, but essentially the LLM is saying, this isn't a message response, this is a tool call, where I want you to go off and call this function and then get the result. There we go. So you're passing in the arguments that came from the customer, and you can pass those into your own function in your own code that kicks off some kind of automated process. And then here is the JSON that shows it what the function was. And with function calling, you can start to give it more and more capabilities. So you can create small little chatbots and mini agents, if you like, that can do stuff. So as well as changing the delivery address, I could go in here and create a second function, which I'm about to do in a second, past me. There we go. Okay. Let's say we want to give our chatbot the ability to search our knowledge base. Now, in the past, people have made chatbots that have used fine-tuning to tune a chatbot on all of your knowledge base so that it can respond about your own data. But you actually don't need to do that with function calling. You can just create a function called search knowledge base. And if at any point during the conversation, your chatbot needs to do something from your knowledge base, then it can just call this function with a search query, and you can give data from your knowledge base. So we're going to do that here. We're going to say, how do I view the status of my order in my dashboard? The AI won't be able to do that, so it will make a function call to search knowledge base with this search query. So what we do on our side in our back end is we read this function call, we go off and we search our database for this query, and then we come back and send the response back to the model. We could just send the response back to the user, but the advantage of sending it back to the model and getting a response back is that the model then can put this into the context of the wider conversation. So we've responded with some data from our knowledge base, and the AI assistant, or the LLM, has basically said, here's the response that you wanted in the context of the conversation that you've already been having. So that's great. You can do some more stuff in here. You can basically respond anything you like to it. So if I go into this response, which I think I will do in a second, there we go. Yeah, so if I respond that here's the text from my knowledge base, and here's a URL that the user can call to find out more information, or this URL is somehow associated with it, then the LLM will actually return with a way, way more interesting response, where it'll actually say, you can visit the orders dashboard, and it's got the URL of their order dashboard. So suddenly we've given our customer support chatbot the ability to change the delivery address on your order, and the ability to search the knowledge base and come back with actual deep links into your platform, all just by putting a couple of function calls in there. So that's my little demo. Now, I think that's it. For those of you that have used function calling before, and I don't know, has anybody here used function calling in OpenAI before? Cool, so not a huge number of people, right? For those of you that have used function calling, might be thinking, this isn't revolutionary, this isn't an AI agent, you've just given some functions to an LLM. But my point there is really, that is quite revolutionary. The ability to take some text and send it off to an LLM, and the text in this case is a description of a function, the ability to do that and to have the LLM control parts of your automated process really is quite revolutionary, and it really is the beginnings, the absolute beginnings of creating an AI agent. And all of the other stuff that I put on there, user interaction, we talked about that, how it can email people and it can do that sort of stuff. Decision making, we've talked a little bit about how it could use the decision tree. You don't have to just do if statements, you could pass your decision tree into an LLM and say which path down this decision tree do you think I should take. So again, LLMs can help there. Learning, we've talked about before, about keeping a context of everything that's happened, labeling the context, and using it to renew your processes. Reasoning, what does reasoning even mean? LLMs can do it as best as humans can. And autonomy is just kicking off scheduled jobs from time to time. If anybody's watched OpenAI's news, they've introduced this new thing called tasks in the OpenAI API, in the ChatGPT UI, where you can say to OpenAI, every day I want you to go and check the stock market for you. It's just a scheduled job. It's just a piece of code that runs every day. There's nothing revolutionary about, autonomy. Autonomy just means that your code doesn't just run in response to a user input, but it just runs every hour or something like that. So really, that is everything that goes into an AI agent. It's nothing magical. The magical part is the LLM and the application of the LLM. So that brings me to the end of my little monologue. Next, we are going to have a little break. So why don't you use the break to chat about the hackathon and decide if there's anybody in this room that you would like to join a team with, the AI hackathon. And then we're going to come back and we're going to hear from Courtney Kyle with her talk, Artists versus AI. We'll be back in 5 minutes, 10 minutes, 10 minutes.